Students, I want to discuss some terminologies related to genetics, genetic terminologies. For understanding the field of heredity or genetics, you have to know the basic terminologies. Number one, phenotype. What is phenotype? So it refers to the external visible appearance of an individual or external expression of an individual. By mere view, one can say the height of the plant, the color of the cotyledon, the shape of the seed. So that's why we say external visible appearance or the external expression of a character or a trait. That is called phenotype. For example, if we are taking the height of the plant, garden pea plant, there are two different varieties. One is tall and one is dwarf. We can see that one, we can identify either tall or dwarf externally. So that is called phenotype. Now, either the tall or dwarf, they are produced by genes, the factors according to Mendel. They are present in the chromosomes. They are only being expressed to form a particular character or phenotype. Now, if you are taking a tall, the tall character is produced by a gene, capital T. I'll tell you the reason later. And the dwarf character is produced by the gene T. Generally speaking, the height of the plant is controlled by T genes. It may be either capital T or small t. So the capital T denotes a dominant factor. The dwarf, small t, that denotes a recessive factor. We'll discuss what is a dominant factor or recessive factor later. This is the method of giving symbolization. If a particular character is a dominant factor or a character, then the first letter of that trait has been taken as a gene. Here you see cap. We have to represent what is the T gene. We are not going to take what is called D instead. You have to take small letter, that is lowercase small t. So, capital T is the dominant factor and small t is the recessive factor, commonly called orally the T gene for the height of the plant. What are the factors responsible for the tall character or dwarf character? I mentioned already T is the factor of the gene controlling the tall character. Now, normally if you are taking any chromosome, they are found in pairs. Let's assume the gene T is present in the first pair of chromosomes. Namesake I am saying. In the fifth point, like this. Now, here the two genes in a homologous chromosomes are similar. Or, we have the same chromosome, the first chromosome, the fifth point. Sometimes the genes may not similar, alike, that is unlike. So this is alike and this is unlike. So taking single letter that denotes a gene, we are writing two letters together and these two letters together constitute the genotype. What is genotype? The genetic constitution of a trait. Genetic constitution of a trait. Because for the expression of a character, two genes are needed. They are being present in a pair of homologous chromosomes. That's why we are using what is called two letters to express a genotype. Or, see that one here, the two letters are different but T1. So at a particular locus we have only a particular gene is present. Here the T gene, it may be capital T or small t. In both the chromosomes we have capital T's. In both the chromosomes, one chromosome has capital T and the other is small t. Or we have, in both the chromosomes we have small t's. So this condition represents what is called the genotype. What is called actually the genetic constitution of a particular trait responsible for the expression of that particular character. The genotype may be of same type, the letters or different letters, or here same letters. Accordingly, we have two different types of genotypes. One is homozygous. If we are taking the genotype homozygous, the two factors are similar or alike in both the chromosomes. like this. Either dominant factors or recessive factors. Either dominant factors or recessive factors. We have in both the chromosomes, the genes are of same type. So, if the genes controlling a particular trait are similar alike in both the chromosomes, then it's called homozygous condition. The two genes for a character in homologous chromosomes are similar or alike. Then if we are taking another one, suppose one we have capital T, another one small t in the fifth locus. Here there are two factors in a homologous chromosomes. Again the first may not be similar or actually unalike. So such a condition is called heterozygous condition. Such a condition is called heterozygous condition. So in homozygous condition, the two genes for a particular trait are similar in both the homologous chromosomes. In a heterozygous condition, we have the two genes of the same type. What is called T gene is different, then it's called heterozygous. So alike and alike. These are two more terminologies. Phenotype, external visible appearance. Genotype, the genetic constitution. Homozygous, similar genes in a homologous chromosomes. Then heterozygous condition, dissimilar genes or unalike genes in a homologous pair of chromosomes. Now some more terminologies. What are alleles? What are alleles? What are alleles or allelomorphs? What are alleles or allelomorphs? Now if you are taking a gene, I am taking for example capital E, this is a factor gene. Its alternative form controlling a particular pair of contrasting character is called an allele. So capital A is allele to small a or small a is allele to capital. So a pair of genes, a pair of factors making up contrasting characters are called alleles or allelomorphs. For example, similarly I can say alternative form of the same gene. Orally I am saying A gene. The two alternatives of A gene are called alleles. Suppose we are taking for example capital T for tall character and small t for the dwarf character. These two are alleles. We are just comparing the same gene in alternative form. The alternative alphabets are called alleles. Similarly we can say. So alleles are the alternative form of the same gene affecting the same trait. Here the height is affected by either T or small t genes. These are all alleles or allelomorphs. Then, what do you mean by a dominant character and a recessive character? Dominant and a recessive. Dominant and recessive characters or trait. I am using the word. We are using the word traits in genetics. Suppose we are crossing two varieties of plants, that is different form, two different form of the same trait, For example, I am taking the height as a character. One variety that is tall, another variety dwarf. One variety tall, another variety dwarf. These two are the different forms of the same trait, what is called height. So when these two plants, which are pure breeding, the meaning for pure breeding, they produce the same type of individuals for a number of generations. Normally the pure breeding varieties are called homozygous individuals. The homozygous individuals, this is the genetic term, genotype, they are nothing but the pure. So here normally suppose we have the two genes are similar, then it's called homozygous, otherwise called as a pure breeder. It is also a pure breeder. This is homozygous tall, this is homozygous recessive. Why we are calling this one as a recessive one? So when two reproducing varieties are crossed, these are called the parental varieties. I am using the letter P1 because these two are taken as the parents to begin with the experiment. Now, The next generation, what is called F1 generation. I will explain this one, the F1 generation. So, the seeds of the plants, which are normally, actually the seeds are raised into plants. The seeds are normally developed by the crossing of two pure breeding varieties that resulted in what is called the first generation. When two pure breeding varieties are crossed, we are getting the plant variety or animal variety that represent the first generation or F1 generation. F stands for filial, a leaf, first filial generation. So the plants which are raised from the seeds of the pure breeding parental cross constitute the F1 generation. So here when tall is crossed with a dwarf, we are getting what is called the tall plant. That is, it is being developed from the seeds of the pure parental cross. Now here, as a tall appeared, that character which expresses itself in the F1 generation is called as a dominant dominant character. The character which expresses itself in the F1 generation is called the dominant character. Now here the tall is the dominant character. To honor that one, the first letter of the tall word is given as a symbol, the G capital T, for the dominant character. So this is a dominant factor, and this is what is called the tall as a dominant factor. The dominant character. So the meaning for that one, the character which expresses itself in the F1 generation is called as the dominant character or trait. That is expressed by a gene capital T. By honoring the first letter, we are taking T as a gene, as a symbol for that one. Another character dwarf, which is being masked or which is being suppressed, which is not being expressed, is called as a recessive character. That character is controlled by the gene, the alternative form of capital T, small t. So the character which is being suppressed, which is being masked, is called as a recessive character, and the gene is called as the recessive factor. So that's about two more, dominant and recessive. Now what do you mean by F2 generation? Now this is, the P1 generation is what is called a cross-pollination process or cross-fertilization process. When we are taking two, that is F1 generation individuals, this is called self-pollination or self-fertilization, crossing of the same type of individuals. Then as a result, we are getting what is called individuals or the offsprings, which constitute the F2 generation. So the generation which is resulted by the self-pollination or the self-fertilization of F1 individuals constitute the F2 generation. So these are some of the terminologies. Then we can go further while I am talking about. Now, you have the genes, either the dominant gene or a recessive gene, also called dominant factor or recessive factor. Now this is a dominant factor, this is a recessive factor. Now the dominant factor can be expressed both in homozygous condition and heterozygous condition. So it expresses itself both in homozygous condition and heterozygous condition. One dominant letter or gene is enough to express a character. We see that one. That's why I can say the dominant gene or factor can be expressed both in homozygous and heterozygous condition. Whereas the recessive factor can be expressed only in homozygous condition, not in heterozygous condition, because in heterozygous condition its effect is masked or suppressed by the dominant gene. So this is about what we have. Capital T, the dominant factor, can be expressed both in homozygous and heterozygous conditions, whereas the recessive factor can be expressed only in homozygous conditions. So these are some of the terminologies regarding what we call the Mendelian experiments. Now he conducted experiment in garden pea plant. He considers in some experiments only one character. He considered normally two or more factors at a time and their inheritance in some other experiments. Now accordingly we have different types of processes. What are the different types of processes he conducted? One, monohybrid process. So in your syllabus given two types of processes, one monohybrid cross, another one dihybrid cross. What is monohybrid cross? Crosses involving the inheritance of only one pair of characters or only one pair of genes. Crosses involving actually only one pair of characters or only one pair of alleles or only one pair of genes constitute monohybrid cross. So, for example, it is a cross between two forms of a same trait. Two forms of a same trait. Crosses involving the inheritance of only one pair of characters is called monohybrid. Are called monohybrid processes or is called monohybrid cross. Here it is a cross between two forms of a same trait. What is the two forms of the same trait? If we are taking the height as a character, there are two forms or two different varieties. One, the tall, another one, dwarf. So these are the two forms of the same trait, what is called the height. The height. We are taking two varieties or two forms. So that is what is called monohybrid cross. We are making a cross between tall and dwarf. These two are a pair of contrasting characters. What are the results we are getting by making a cross like that? I mentioned already what is F1 generation. The plants that are raised from the seeds of two pure breeding parental cross. Pure breeding parental cross. The plants that are raised from the seeds of two pure breeding parental varieties. That constitute what is called F1 generation. Now what he did in the experiments, he did what is called artificial cross-pollination. So the plants, you know that one bisexual, each flower has both andration and gynoecium. He did artificial cross-pollination. Artificial cross-pollination. For that he did one process. The name of the process is emasculation. 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 For his experiment, he did one process, what is called emasculation. This is nothing but the removal of anther from the flower. To prevent self-pollination or to dust the pollen grains on another flower, he removed the anther, the stamens from the bisexual flower. Now he did artificial pollination. How? So suppose he is taking what is called the plants with the tall character and a plant with what is called the dwarf character. Dwarf character. He removed the stamens. This is a stamen. And this is what's called the stigma. Removed the pollen grains, or he removed first what's called the anther from the dwarf plant and dusted the pollen grains and the stigma of the tall plant to effect what is called cross-pollination. So this is called artificial cross-pollination, not natural cross-pollination. He removed the anther from one plant with the dwarf character and dusted the pollen grains and the stigma of the flower of another plant with the tall character. This is called cross-pollination, artificial cross-pollination. And want to know the results in the first generation, second generation, etc. So this is what is called artificial cross-pollination involving removal of anther and dusting of pollen grains and the stigma of flower of tall plant. Now, what the results he obtained? The following results are obtained. The following results are obtained. Mendel did monohybrid cross by taking the height of the plant. As far the height is concerned, there are two different forms. One, the tall, another one dwarf. Now here represent the parents being one, the phenotype tall and then dwarf. These two are called pure breeding varieties because they have similar genes for a character and produce the same variety for a number of generations. For example, when two tall varieties are crossed, they are producing the same variety. Then they are called the pure breeders. Now, here the two pure breeding varieties are taken, they are crossed. The pollen grains are removed and dusted on the stigma of the flower, either from the top or from the top, etc. as the case may be. Now the tall plant produces the gametes. All the gametes are similar, each with one dominant factor or gene, capital T. So while we are writing a simply letter that denotes a gene, while encircling the letter that refers to the gamete. So two gametes of same type. Similarly, the dwarf plant produces two gametes of same type. Now the fertilization occurs. The union of the male and female gametes occur, leading to the formation of the seed. That seed produces the F1 generation in the form of all tall plants. All tall plants. So all tall. And all have the same genotype of heterozygous condition, capital T, small t. As tall is the dominant character, now the recessive factor is being masked. So heterozygous individuals are produced in the F1 generation. Now these individuals are called F1 hybrid or monohybrids. Monohybrids. The meaning for that one, they are differing only one pair of factors, hence called monohybrids. When two monohybrids of F1 generation are self-pollinated, here it is called self-pollination of F1 individuals, taking the two heterozygous strand. Now, as here we have the heterozygous condition, these tall plants produce two different types of gametes. 50% of the gametes with the capital T and 50% of the gametes with the small t are recessive factor. So both male and female actually, that is the ovule or the pollen grains, are of two different types. Now the probabilities are we have to make. If you have the gametes of two different types on either side, the probables are 2 into 2, 4. So that is the way you can have to calculate. If you have 4 gametes on either side, 4 into 4, 16 individuals are formed. So like that we have 2 gametes on either side. So the probabilities are 2 into 2, 4. Out of the 4 individuals, so in that class, while he did experiment, he received totally 1064 individuals. Out of this 1064 individuals, 787 are tall plants and 277 are dwarf plants. The seeds are raised, they produce the plants. Out of the total plants of 1064, 787 tall, 277 dwarf. He made into just what is called a ratio. Out of the 4 plants produced here, let us consider like that. 3 plants are tall. 3 plants are tall. And 1 is, that is dwarf. That means 75% of the plants produced are dominant character, that is a tall character. 25% of the plants produced are having the dwarf characters. So this is 3:1 ratio. We are converting these numbers into the ratio 3:1. So it can also be represented, the F2 generation can also be represented in the form of Punnett checkerboard. Now the Punnett square is a checkerboard form. Normally this one is devised by a British geneticist, Punnett. Hence the name Punnett checkerboard. What is its use? It is normally used actually to show the possible probability of the genotypes. Possible probability of the genotypes of offsprings that resulted in a genetic class. So here, as we have 4 individuals are produced with the 2 different types of gametes, I am taking the female gametes on upper one and laterally I am taking, that is the male gametes. Simple multiplication. So this gamete fuses with this one, we are getting what's called capital T. This one also has the ability of fertilizing this one, so we are getting this variety. This gamete also has the ability of fertilizing this gamete with the dominant factor, and similarly also has the ability of fertilizing this recessive factor. So this is a one what we are getting. Now these 3 are what is called the top, and this is what is called the dwarf. This is the dwarf variety. So that's why we are getting the ratio. The external visible appearance based on external visible appearance, we are getting 3 tall, 1 dwarf, and this is called phenotypic ratio, 1 dwarf. If we are taking actually the three tall plants, out of the three tall plants, we have one is homozygous, another two are heterozygous. So, based on the genetic constitution, we can make a ratio that is called genotypic ratio. That is called genotypic ratio. What genotypic ratio we are getting here? I am writing here. Genotypic ratio. Out of the three tall plants I mentioned already, one is homozygous. This is a genotypic ratio of monohybrid cross. So one homozygous tall, two heterozygous tall, one homozygous recessive. So we are getting what is called 1:2:1. This is what is called the genotypic ratio, and the phenotypic ratio is 3:1. So these were the results obtained in monohybrid cross, just normally demonstrated by Mendel. So you can make use of this checkerboard for clear understanding. That's why I'm using that one also. Or you can make that one in this way. The random fusion. This is what I represent, the random fusion of the gametes. The same one will also be represent the Punnett square. So this is about all that is the monohybrid cross, the phenotypic ratio of monohybrid cross, the genotypic ratio of monohybrid cross. These are the one-word answers. The phenotypic ratio of monohybrid cross 3:1. The genotypic ratio of monohybrid cross 1:2:1. One homozygous tall, two heterozygous tall, one homozygous recessive. The following interpretations were made by Mendel based on monohybrid cross. He just concluded that the transmission of factors occur from one generation to another generation. These factors are now called the genes. Mendel didn't use the term genes, used only the factors. The term gene was used by Johansen. Johansen only used the term genes. This is number one. Now the two factors responsible for either tallness or dwarfness. For example, for tallness we have the factor small t, and what we have the dwarfness, the small t. So these letters represent the factors. They are being passed on to the next generation through fertilization, through reproduction. Now these factors may be present or may be alike. For example, in a particular pair of homologous chromosomes like this. These factors are alike either for tallness or for smallness, or they may be unlike. For example, if you are taking another homologous pair of chromosomes, now these factors are unlike. So when the factors for a particular character in homologous chromosomes are alike, now the condition is called homozygous condition. Here the factors are alike. When the factors are not actually similar, then the condition is called heterozygous condition. The factors are unlike. Now this is heterozygous tall and this is homozygous tall. This is homozygous tall. This is one of the contributions. Then the factors for making up the second contribution. The factors making up contrasting pairs of characters are called alleles. The factors making up the contrasting characters of a trait are called alleles. Out of the two alleles, here you can see the chromosomal map. One allele is contributed by one parent, another allele is contributed by another parent. So in a F1 generation, one from what is called actually this parent, another one is from this parent, so that we are getting what's called heterozygous condition. So one allele contributed by one parent, another allele is contributed by another parent. So these two are called alleles I mentioned already, contrasting pairs of what is called the factors. Then I mentioned already, when two breeding tall and dwarf plants are crossed, only one of the plant's character being expressed in the F1 generation. The character which expresses itself is called as the dominant character or dominant trait. See here tall, we are making a cross. Then in the F1 generation, what we have discussed already, we are getting tall. The character which is being expressed in the F1 generation is called as a dominant character. That's why we are taking the first letter of that character. And the another character which is being suppressed or masked is called as a recessive. Now this is recessive. This is another interpretation. The character which is expressed in the F1 generation is called the dominant character. The other character which is being masked, masked means actually hidden or suppressed, is called as a recessive character. Then another interpretation. The gametes are always pure. The gametes are always pure. So if you are taking a particular gamete, the gamete contains either capital T or small t. So these four separate entities, unique entities, when they are brought together, the F1 generation, they remain together without mixing. Now during the cross, when F1 individuals are crossed, they produce the gametes, each gamete with either capital T or small t, not both, and then they are being combined and then transmitted to the next generation. So the gametes or the factors are pure. The meaning for that one, during the formation of gametes, the gametes are formed with only one factor, not both, for that particular character. So we can say either we have the gametes are pure or the factors are pure. Now these two are separate entities. They are brought together here and remain together during the cross, during the F1 cross. When F1 individuals are crossed, now they form gametes independently and unite to form a particular individual. So the factors are transferred to the next generation. So this is what we can see. The gametes are pure, the factors are pure. The meaning for that one, they are two separate entities. They are being normally separated, entered into two different gametes, and each gamete has only one of the two from the heterozygous condition. When the F1 individuals are crossed, they normally form gametes. The gametes with each factor just combine together and form the next generation individuals. These are some of the interpretations of monohybrid class.